What I want to do is talk a little bit about why security today, I don't know that I'll say more than ever before, but at least as much as before, why it is so important in the blockchain world, in the digital asset world, in the ledger world, and why we can no longer put it last if you had been. I think there's been a lot of examples recently and ongoing, honestly, of why we've missed security, how we've missed security, how we've prioritized it last. And as a security practitioner, I've been doing this almost 25 years now. It makes me really sad that we keep getting hacked. Blockchain getting hacked is, of course, a horrible way to say this, but when you look at blockchain ledgers being the underpinning of how the world is changing around us, we need to start getting this stuff right. So first, let's maybe talk a little bit about for some of the people who might not have all of the background of where blockchain came from, is sort of why we even care here. I think some people who have been following the Global Blockchain Business Council, who have been around a long time, have heard that the world is changing with automation, with computing, with the internet. 10 years ago, 15 years ago, we were just learning about Google. A few years after that, we were just learning about how to buy stuff online. Now we are connected everything. We're connected IoT devices. We are summoning cars. All of these analogies that everybody is used to. And that's really cool. Like, we're now at the time where AI engines and robotics and human compute power and humans are starting to combine these sort of things in a way that we have never combined it before, where it can be useful to us. In here, baked underneath these offerings, are things like monetary system change, Bitcoin, tokens of transfer, tokens of assets. You need all of these sensors and interfaces to deliver these business services, to deliver these human changing services. And when you sort of break it apart, like I will here in a few minutes, I think what's underneath this revolution is the ability to use, not just use these things, but to use them together safely, to use them together in a way that it will not do more harm than we intended. I would hate that these systems work together and make life worse. So when I take a look at what a blockchain is, I simplify it into sort of this kind of general set of things, right? A blockchain is a big long list of data. It's probably on disk or in memory, managed by software, secured by math, all these things, protected by consensus, installed with code. What's interesting about what this is, when you read through at the simplest level, and I certainly am not going to get into an argument of people about doing this with a graph or a ledger or consensus or public or private or a DAG or in a database itself. But what a blockchain is simply a way to securely prove that something happened. And you guarantee that it happened. You guarantee it happened using computers, using math, using programs and scripts. When you sort of look through these probablys and hopefuls, the vast majority of these blockchain, digital asset, ledger type projects fit this general pattern. As a data center designer, as a person who has worked in this for a long time, what this means to me that it can be controlled, it can be managed, it can be handled by things that I'm used to, right? I know how to handle data, I know how to handle memory, I know how to handle software and math. So can I start to apply some of the security controls that I know from the past? Can I apply them now to this new world of fully automated, foolproof? I think I can. I think when I start to look at this, I see a reason to have security in each of these layers, because each of these layers have a different set of threats, a different set of risks. They're used for different purposes. They're stored and controlled by different types of people with different varying skills. Security has to come into there with those compensating controls. So when I take a look at what I am really doing here, And I'm trying to move the window out of the way so I can see this question. Sorry, I'm stuck with a Q&A screen in the middle of this. Well, I'll move it out. When I start thinking about what the blockchain is, I think it's guaranteed the truth, right? That's what I hope it does. I also think that it's guaranteed to be real time, whatever real time is. Like, I want the truth now. And it's guaranteed to be secure, which, you know, means was confidential. I only see it if I need it. The information is accurate. The information is secure in the manner that I need to. And so when you take a look at sort of the purpose of these systems, you end up where I need this sort of underlying thing of security to have a really important role in this overall system. And I hope that you're one of the types of people who are like this. Like, this is the guy who is getting ready to watch the train wreck. I've heard a lot of people, you know, I'm a blockchain believer personally. I'm a ledger believer that it has a purpose in the world. There's a lot of people out there who are like, oh my goodness, let's just go watch this blockchain thing fail. You know, in some cases, like, let's not help, let's just stand back, they'll mess it up and they'll see that the old way is better. I don't believe in that. I believe there are uses for this, and we need to bring security to the forefront. When we can't change my slides, there we go. When I think about what I need to do here, I go back to the original set of cyber controls. And I'm not talking about blockchain right now, I'm talking about security, right? Confidentiality, integrity, and availability are a couple of the most important things that exist here. You have to put this in every single system that you build. I don't know if there's a system out there where you can not have these things. So why not break them into blockchain? And what does that mean? Let's maybe talk through some blockchain use cases. Let's talk through some situations where, you know, this maybe matters to people who are more in this industry. But before I do that here, let's sort of talk about what this means here. When I look at what a blockchain is for, I think that I have, there we go, a list of trusted devices, or a trusted entry point with accurate data, right? We need that data to be accurate. If you put bad data in a permanent place, it's just permanently bad. You send it to a trusted recipient, somebody you know, somebody you believe, you know the target, you determine the target, it doesn't just go somewhere randomly. The data is securely held. It's then put in unmodifiable storage. That's kind of the ledger, the blockchain part. And we have operational controls around it to protect it from being messed with afterwards. When I sort of take a look at the point of any of these systems, which is the benefit, you know, of course you could argue the consensus part is the benefit, and removing the trust of existing third parties. I don't want to argue the politics around that. I just want to look at the point of the system. Look, I have trust with accurate, with trust, with security, unmodifiable. Like, this is about security. And what I want to do is challenge everybody who's watching this and listening to this to think, if I needed to build a system that had the data that was right, it was right all the time, you shouldn't mess with it. The data has to be securely held, and you have to build operations around it. A lot of this is process, but a lot of this is sort of traditional security measures, slightly modified security measures that we've built over the years. And when I think about any system and design any architecture around a blockchain or a ledger, or even building a physical data center, I think about things like this. This is my grounding point. What does the system attempt to do? Getting a spam phone. The situation with this leads to a different way to look at the stack, where you have to think about, what is the best place for a blockchain or a ledger in my system? Which things are traditional sort of things We know how to do trusted communications protocols, for instance. We're not reinventing that a lot of the time. Generally, in a system like this, the blockchain fits at the trusted commit, the data consistency, the consensus, that sort of level here. And so when I do this as a stack diagram, some of these things are done in sequence, right? If you're doing something like the food trust network, if you're verifying supply chain or such, you want that data to be good at the very beginning. You want the human to be putting that in the process. As I am putting that through the system here, I start to build upon my underlying foundation. In some of these things, blockchain isn't the bottom level. The source of the data is the bottom level. The protocols are the bottom level. And again, this kind of stack diagram grounds me when I have conversations with people about whether they need security or not. So let's talk about one of the big things that goes in most automated system, and that is the concept of smart contracts, right? For those of you who have never heard of a smart contract, it's essentially a program, a line of code, where a set of predetermined or easy to determine logic steps automatically execute when the conditions are met. In the most simplest case, it's I'm going to send you $1, so it executes send $1 from my wallet to your wallet. In the more complicated use cases, it acts as an oracle or determining values of things. It acts as a bridge between different kinds of networks. It adds a decision-making process. You're allowed to do this. Do you have rights to do this? Do you have authorization? Are you encrypting it? Is it where it needs to be? Your smart contract can essentially do whatever you want. And in a language set, especially when if you were to argue that part of the automated process in Ethereum, you can do anything you want that's Turing complete. What you can actually do is seriously anything you want, which means you can mess it up. I believe that humans are fallible. I believe that humans make mistakes. And when you automate something, you can automate it badly. You could theoretically drive a self-driving car over the cliff because it has a bad action that it takes to a predefined action. We've heard, what happens when a human walks in the road with a self-driving car. Does it go around it or does it hit it? That's a predetermined thing that the car has to decide. In the monetary world, it's usually moving tokens around or deciding if you're authorized. But I think when I step back and I think, look, I'm about to automate a permanent thing. Like a smart contract generally doesn't have an undo button, does it? Like we building these things to be irreversible, or at least you have to roll it forward, right? So if I'm building a piece of automation, I have to think slightly differently than I do in regular enterprise contexts, right? When I'm in an enterprise, I do automation to reboot a server, right? If I mess it up, I just go in there and fix it. When I am doing a smart contract for something legal or something that is moving value around, and I am moving it to a system that I don't control, this, to me, seems like a pretty important area to focus extra attention with eyes and audits and systems that are good at it, pre-baked things. At this point, we don't reinvent math. Maybe it's getting to be the time where we shouldn't reinvent smart contracts. We should use common smart contract languages. So this is one of the big parts when I think about security of a blockchain or a ledger system. Whatever does this automatic execution, call it a smart contract or whatever it's called in the system, is one of the very first areas that you think about for a security review. So the second thing is, so I want to combine this sort of concept around what we do when there are tokens that we think have monetary value, right? Decentralized finance, maybe you want to stake your tokens and get some kind of interest out of it. Maybe you want to swap them from something else. In the old world, you change dollars for lira or shekels, or you you loaned the bank money to get interest on. In these general blockchain worlds and sometimes the world of decentralized finance, you do all these sort of things, except if you think about it, you're taking it from a mathematical thing, which is a wallet. You're using an automatic system of a smart contract to do an action that you think will have an outcome. And you want it to actually work every time, right? You do not want the system to take your money. There's humans in the old process. There's humans in the centralized world to sort of make sure bad things don't happen. I'm not saying they don't stop bad things from happening, but I'm thinking that they stop it maybe more than some of the automated scripts we've seen out there. But these are really just wallets and smart contracts. All these cool words around DeFi and staking, really it's just wallets and smart contracts. On the centralized exchange side, right, it's a little bit bigger and more than that. It's wallets with process, AML, KYC, compliance, rules, multi-party computing, back office processes. When I sort of think about building this sort of financial system on a blockchain or a ledger, I think, okay, I am moving money around, which means I need some processes to make sure people don't get hurt. That's a security and compliance control. But then I also think, look, if I am automating this, if I am taking people's money into this system, I need to break these pieces down and make sure that each piece, and then the integrated part of it, is as secure as it needs to be. It's very interesting to me how we, even as recent as this last weekend, we see hundreds of millions of dollars being removed from these places because of a theft of a single thing. You know, if you lose a private key, you lose all your money. Like, that just doesn't seem logically right. Like, as a security person, that's not a risk profile that I'm used to, the sort of one and done profile. It's actually pretty funny to me individually that, you know, people are like, hey, let's hurry up and get rid of these centralized things because we have consensus. But then we have a bad thing happen where people lose money and they hurry up and call all the centralized places to stop the money from getting taken, right? We're trying to build all these security controls into these decentralized systems, but we still rely on manual processes in centralized systems to protect us. As a security person, that's a compensating control, and it's really useful. But when you're building these kind of systems, you definitely need to decide which one of these you want to prioritize. And to me, the most important aspects of this is how you're controlling the wallets, which is the keys, the access, the entitlements, how you're controlling the automation, which is the smart contracts, and then where you store that, right? Do you store that in some mathematical thing, multi-party? Do you shard it and sprinkle it all over the place? Or do you put it in something centralized where theoretically they have a better skill at youth and security, they probably have better processes. It's hard to argue against a centralized thing with more money, more control being less secure. It's hard to argue that in the security world, but it's interesting to think through. And that's what this talk is about today, is you have to think through these things as security risk scenarios as you're building these things. One of the big things that I'm getting involved in, which, you know, I am the head of blockchain, but I'm also the head of our digital asset team. And what is becoming one of the most prevalent use cases is tokenizing a real world thing in order to do something digital with it. And I'm glossing over how to do this on purpose because this is not a deep technical talk. When we talk about the business purpose of this, right? I certainly can't buy a house with paper using the internet because the internet doesn't deal with paper. In order for me to do work on a house, I need to be able to make the house like a digital thing. I need to make money a digital thing. I need to make signatures a digital thing. I need to make identity a digital thing. I need to make the historical records a digital thing, just to deal with that one asset class. When I deal with money, some part of it is, well, I just want to move money around. I don't care who gets it. When I deal with paintings, well, maybe I want to be able to sell part of that painting. Tokenizing this thing that has a value really is, let me issue tokens against it equal to that value. Let me assign ownership to those things. And then let me allow those people who have ownership, legal ownership or right to transact as, or, you know, whatever the ownership is. Let me build a system to allow this to happen. First, it's one thing to tokenize, right? We can create digital marbles all day. We've been doing it for years. You know, we use a counting system. 20 digital marbles is equal to the value of this system over there, and let's subtract and pay you when we're done. We've been doing that a long time. But when it becomes a real world legal tokenization, that is a real asset, we start to think, how do I take a real world law? How do I translate it? When I look at a token, I need to know who owns it. I need to know where it came from. I need to know where it's going. Sometimes I need to know the entire provenance of it in the case of a house. Sometimes I need to know how many there are, and I can't create more. I can never burn a Picasso token because I can't like chop out part of a Picasso. But maybe I want a disposable asset. You know, I want to just use digital marbles. You pay for them, and when you spend them, they go away, and then you run out. Right? We've sort of done with digital gold type systems and games with like that for years. But when you think about assets, what people are really interested in my world, when they talk about tokenizing the assets, they think about a couple of use cases. So first of all, if I have an asset that's money, you better take care of it like it's money. Like, don't let somebody steal it. That means store the math goods, store my wallet, put it in your digital safety deposit box. All those things around theft. When you think about moving it around between chains, when you think about selling it to somebody else, you want to know that you're not going to get blamed for it being illegal. You want to know that you're not going to get blamed for being fraudulent. Like, oh, you sold me a house that was fraudulent. That can be a thing. And I say this a lot, and it's almost kind of silly. When you look at this and you think about the security, you sort of have to take the, well, that shouldn't be a thing approach to this. The idea that somebody could get their mathematical key stolen and then be broke shouldn't be a thing. Like, I understand the reason why some purists out there in the decentralized people like understand that that's a progress towards a different kind of world. But the fact that you could get a single thing stolen and then be broke shouldn't be a thing. And that's a security problem to solve. A organization getting hacked and everybody is all of a sudden broke or less rich shouldn't be a thing. Like, these are problems that I believe we can solve through continuous work and audits and assessments and technology that safely stores these assets in a place where nobody can get to them. We have processes that compensate for when something bad happens, right? This is why we build layers around systems. Custody is a really interesting thing in the world today. We all maybe have a different definition of what custody means, but for right now, and actually most of the projects that I'm personally working on at Kudelski right now are about how to do custody. I don't really ever get involved with whether it's legal or not to hold somebody's keys, or whether it's legal or not to sell their Bitcoin when they did something bad with it. Like that, I try not to play in that space. The part about custody that's really interesting is the security component. How do I take something that is digital in nature and fallible, like can be lost or stolen or deleted or abused, and truly make it safekeeping? How do I safekeep? How do I guard this asset, this key that is used to do like really important transactions? When I think about a custody system, of course it has every business control in it that you need to actually deliver these as a business service. When I think about custody technology, I think about the systems that interoperate with the blockchains, that are able to be adaptable to my use case, that are able to hold my keys in a way that makes them such that I don't have to handle the use case where something is just lost forever. I don't think it should be a use case. My apologies for stopping my snoring dog there. My situation around custody is that we're getting to the point where it doesn't make sense to build your own stack of custody, right? I'm a believer in pre-built secured systems. When I think about custody, I think, there's a couple of ways to do this out there, and I'll talk about this in a minute. There is the build your own way, which is a whole bunch of open source stuff. There's a data center way, there's a third-party way. Because this is so important, you can't leave it to the amateurs. You bring in security professionals, you bring in mathematical professionals, you bring in cryptographic people, you bring in companies to talk about custody and how to do it right. This, I think, is going to be a really important thing over the next 10 years as especially banks in the US start to do custody more and more and more for their US customers. And look at that, there's a picture about custody here. So custody to me is, it maybe starts with law. The reason it exists because it's legal. The reason you want to do it is maybe because it's worth money. But how you do it, if you sort of look at my made up stack here, there's 4 options. There's integration, there's policy engines, there's business logic. Like most of these things, when you think about it, is how do I know who? How do I know, and hopefully you can see my mouse here. How do I know what? How do I discern where? What kind of policy do I apply? Where do I get the information from? what kind of cluster blockchain, where do I put this stuff? But then how does my math work? Like, how do I do the secure safety part? You know, today regulations for banks often require secured physical data center with a secured physical thing storing your keys. In sort of the new decentralized world, some projects have gone fully to math only. Math with iPhones, is that as safe as a secure vault in a building? No, nobody's really proven math is better than physical protection. I am a believer in cold storage and data centers personally. I don't think our compensating controls over math only are there yet. There is a lot of different ways to do this picture. This is sort of one that I drew for a project. There are different ways to build these boxes, I think is my point. But this flow is a very common representation of what we see as a digital asset system from a functional perspective. I want to answer one of these questions that came in here from Tony. There's a lot of crypto exchanges and presumably people who are good at this. Why do they keep getting hacked? There is no way to beat the bad guys all the time, full stop. There are ways to put in layers and layers of compensating controls in place where it becomes harder and harder and harder to break into these systems. I think what we have seen with these hacks lately is that they've skipped these compensating control steps. When you have a single private key getting stolen, to me, they should have thought about multiple keys and multiple approvals. When you see back-end workflows getting compromised up here in like the custody services application business logic, if you have a single change in rules and a business logic that results in you being able to take all the crypto, to me, that was not good enough compensating controls. If you have a single PC compromised where, you know, that company's hot wallet was stored and they just get a virus equivalently, to me, not enough compensating controls were in place. I actually haven't seen, I would actually like to know about an attack where the attacker broke through like a NIST quality of controls that were in every system. Like, I would like to see how they skipped, they broke through multi-party, they broke the algorithm, they broke into the server when it had, you know, secure logic in it. They broke through the user access theme with 2FA. Generally, all the same attacks have happened in crypto exchanges as they have in traditional enterprise, which is they steal the account, they steal the wallet, they steal the key, they steal the password, they break in when it wasn't patched, they come in through unsecured instance, or they change the rule set. Like, these are pretty much the common attack vectors. Very few people attack the blockchain and the math anymore because they don't need to. In the United States, we're having where legalization is starting to happen now with custody. And David, this I think is a really interesting area for you guys here. And just yesterday, the House passed something in the US, the Digital Taxonomy Act. They're like, hey, let's be a leader in blockchain. Like, we need to have a strong digital asset market. So, you know, maybe the US is going to invest a ton of money for catch up now. Maybe we'll catch up to the rest of the world. But like, if any part of this starts getting hacked, legislators are going to turn it off. And it is in our best interest to make sure that the legislators don't turn it off. Moving into the enterprise here real quick. I actually think that there's a lot of cool enterprise use cases for ledgers and blockchain. I think that we have settlement and finance and proof of organic and all these things going in the enterprise. And if you're in the enterprise, you might just be like, it's the blockchain, I don't need to fix it. But actually, I guarantee that your enterprise policies and processes do not match with what happens in a blockchain. Your standards say something like rotate the key every year. Your standards say something like we must test a disaster recovery plan every year. Your things have access management rules with passwords. Passwords have to be 8 characters long, but a key sequence is 2000. Like, you have to take a look at your standards and policies that are probably based on NIST or ISO. And yes, we probably do need a new standard for how to do blockchain in enterprise language, because you have to think about all of these things. I think that if you take a look at your top 20, like NIST or SANS have done for years, which is, let's just scan it, let's catch the problem, let's fix it. With the blockchain world and ledgers and all these things in the world, have to talk about, let's plan up front to be secure, let's design it to be secure, let's prevent the attack in the first place. And of course, operations at the end, but like that's what we need to do inside of enterprises, and we haven't started. We're starting to get calls at Kudelski to help enterprises figure out what blockchain means. And when they, again, like go to this like reason we do this, cybersecurity is the foundation of every component of this. A secure by design methodology is more important, or equally as important, as does the system do what you intend? There's a lot of unique ways to do movement in math, but if it's not secure, why would you do it? And David, before I turn it over to you, I wanted to spend a minute to talk about Kudelski here. So the reason I'm here today is, we do a lot of really cool mathematical things inside of Kudelski. We're a 60-year-old company, and we have hundreds and hundreds of cryptographers who build the things that make some of these systems work. In my blockchain team, and please feel free to reach out at any time, we do this sort of full stack of things that make these things work. I think it is bad that we allow projects to get hacked as easily as they're hacked today. I think you need to find somebody to help you, whether it's me or somebody else, advise you when you're building, audit it when you're done, help you make the architecture secure, help you do the research, uncover that research to get to that next thing. Buy something from David. However you want to solve these problems, like you have to do these things in this list. This is not a list I made up. This is a list of necessary things for projects. When you do security on blockchain, you need to audit and test it, for goodness sake. Pick somebody who has skill in it. I think I work with some of the smartest people on the planet at Kudelski, and doing some of these sort of weird, unique use cases, and why I work with David and his team. Like, there are cool new ways to solve these problems that have to adapt with the times, and the blockchain is doing that. All these use cases that I talked about today, I sort of want to leave this last sort of statement up here, is if you need to trust the system, it has to be secure. And I will preach that as a security professional all day long. It is not okay for me in the world of ledgers to ever compromise on security. And with that, David, I'll turn it to you to ask some questions or share some thoughts. Sterny, go ahead.